Okay, well, hello. Today we're going to be talking about ratios and proportions. And ratios and proportions are pretty similar, and even ratios, proportions, and fractions are pretty similar. And proportions really are just built from ratios. So what we want to do today is kind of show you how they tell us how different groups of numbers and dimensions and sizes and things like that are related to each other. Now, ratios, they can be reduced, just like fractions can be reduced. So we'll do a little bit of that today as well. And you'll find that the calculations that we do today, we'll be setting up some fractions. We'll be doing some cross products with some multiplying and some dividing. And we'll use a little bit of algebra to solve for an unknown. But you'll find that with these ratio and proportion problems, that most of the calculations that we do are very similar. So even the algebra will be very similar, regardless of what types of problems that we're working on. So the thing that that we need to remember with ratios is to read the problem carefully, because the order that you read things and the order that you write them down on your paper is important. So I'm going to take you to my screen, and we're going to work through the first example where we look at some proportions. So share here and find my presentation. So in this case, we see a bunch of coins. And as you can see, we have 4 nickels. And if you counted them, we would have 12 pennies. So what we want to do is look at the ratios that we can see here. So first, let's look at the ratio of nickels to pennies. And remember, I mentioned that order is important. So what we'll do is we'll look at the number of nickels, which was 4, and the number of pennies, which was 12. And so the way that we show that is with a colon in between them. So this means 4 nickels to 12 pennies. So nickels first, pennies second. Now, if we wanted to look at the ratio of pennies to nickels, then since we care about the order, we have 12 pennies and 4 nickels. And if we want to look at the ratio of nickels to the total number of coins, and you will see problems that are like this too, where they ask you to look at maybe a few things at once. We know that we have 4 nickels, so that's going to be 4. But when we look at all the coins, we've got the 4 nickels and the 12 pennies, which add up to 16. So in this case, the ratio of nickels to coins, to total coins, is 4 to 16. Okay? So really, it's just a matter of counting and looking very carefully at what we're being asked to count and putting things in the order that we're counting them. So let's look now. And what we want to do now is to simplify. And let me get this a tiny bit bigger. Okay. What we want to do now is to simplify these. And you can do that just like you do fractions. So if we had a fraction that was 4 over 12, we know that 4 goes into 4 one time, and 4 goes into 12 how many times? 3 times. Okay. So we can, just like we reduce a fraction, we can do that for this. Okay, so just like turning 4/12 into 1/3, you can take a ratio and turn that into a 1 to 3. So when we look at the pennies to nickels, we had a 12 to 4. So here again, you can see 4 goes into 12 3 times, 4 goes into 4 once, but look at the order. We need to make sure that the 3 goes first and the 1 goes second. So you have this. So it's a 3-to-1 ratio. And if we look at the nickels to coins, once again, we had 4 to 16 that we figured out before. So in this case, 4 goes into 4 once, 4 goes into 16 4 times. So we have a 1-to-4 ratio. So really, that's the whole kind of thought of what ratios are. They show how things relate to each other. But just to show you how it works when you reduce things, and just another way of looking at it, we said that in this group, we had, for every 4 nickels, we had 12 pennies. So that's one way to look at that ratio. For every 4 nickels, we had 12 pennies. But when we reduced it to a 1-to-3, another way to look at it is, for every 1 nickel, we have 3 pennies. So in all of these cases, and it works out just perfectly. I could have even said 2-to-6, and that would have worked too, because that will reduce from that. So usually we try to take ratios and reduce them as simple as we can get them. So now I'd like to look at one more example where we're gonna look at ratios, and then we'll see how we can use that to turn ratios into proportions and do some calculations there. So first of all, we're gonna make some biscuits. And this is a very simple recipe, just has 2 ingredients. We've got Bisquick and we've got water. And this is the amount that we need to make 10 biscuits. So 3 cups of Bisquick and 1 cup of water. So looking again and practicing ratios here. So we want to find out what the ratio of Bisquick is to water, water to Bisquick, and water to the total cups in all of the ingredients, which are just the 2 ingredients. So first, if we look at Bisquick to water, we can see that we have 3 cups Bisquick and 1 cup water. So the ratio there is 3-to-1, because I said Bisquick first, then water. We take the cups of Bisquick first, and then the cups of water second. Turning it around and saying the ratio of water to Bisquick, then we've got 1-to-3. And if we look at the total ingredients, we see that in the total, we have 4 cups total, 3 plus 1. So if we look at the cups of water to the total cups, we have 1 cup water to 4 cups of the total ingredients. So now let's look at it just another way here, so that because we know that for this recipe, we can make 10 biscuits. So we want to find out the ratio of how many biscuits we can make to how many cups of Bisquick it takes. So it's 10 biscuits to 3 cups Bisquick. So that's 10-to-3. If we look at the ratio of biscuits to cups of water, then we have 10 biscuits, 1 cup of water. So we've got a 10-to-1. So why do we care about this? Well, we can use these when we do a proportion calculation. So let's say we don't want to make 10 biscuits, we want to make 20 biscuits. Well, you can probably see from that we doubled the amount of biscuits. So we want to have double each of these. So we want to have 6 cups of Bisquick, 2 cups of water to make 20 biscuits. So if you did that in your head, you probably, you may have figured out, or you may not have realized, but you used a proportion calculation when you did that. But let's make it just a little bit more challenging. And we'll say that we want to do 25 biscuits. So let's look at what it would take to do 25 biscuits rather than 10 biscuits. And you'll see that when we do this, we're going to use that ratio to form a fraction so that we can do some calculations with some fractions. So let me turn this around and so that we can see what I'm writing here. So let's see. go. All right. So in this case, we've got 10 biscuits for 3 cups of Bisquick. And I'll just do BQ to be Bisquick. Okay, so that's our ratio, 10 biscuits to 3 cups Bisquick. But we want to see how many cups of Bisquick it would take to make 25 biscuits. So we're going to make another fraction that's very similar to this. And you see how we use biscuits on top and Bisquick on bottom. So we're going to do the same thing. We know we want to make 25 biscuits. And we don't know how many cups of Bisquick that we need. So just like most unknowns, we're going to call that X. So we need X cups of Bisquick. Okay? So what we're going to use algebra to help solve. And if you remember, if we have two fractions like this that are equal to each other, we can do
Hey, Bill,
product.
it's very hard to hear you now.
Oh, okay.
It was really easy to hear you about 10 seconds ago, but it got really hard when you adjusted the camera there.
Ah, okay. Okay. So what we'll do now,
Bill, I'm sorry to interrupt again. I can't hear you if you're supposed to be talking.
okay, can you hear me now?
I can hear you now, great, yeah.
Ah, okay. I wonder
But
where
when
the
you were
mic.
cross multiplying, I couldn't hear anything.
I must have hit maybe a microphone or something. Okay, let's see. Is it okay if can you hear right now?
I can hear, yeah, it's a little echoey, but I can still hear you fine, yeah.
Okay. All right, so let's take a look at this, and I'll review what I did. So we were doing cross multiplying, and we had 10 biscuits times X, so 10X, and we had 3 cups Bisquick times 25. So we have 25 times 3. So for that, we have 10X equals 75. So what we want to do is solve for X. So when we remember that when we take a reciprocal or when we divide by the same number, we cancel things out. So we'll take this 10x, we'll divide it by 10. Since there's an equal sign, we have to do exactly the same thing to the other side too. So we divide that by 10. So we can see that if we want to make 25 biscuits, we need X equals 75 divided by 10. We'll do it the long way here. So for this, 10 goes into 75 7 times, 70. And we have to take our decimal point and put it up there. Or we can just look at this as a fraction. So let's do that. 7 5/10. 7 5/10. And for that, camera here. For that, 5/10 equals 1/2. That's the same as 1/2. because 5 goes into 5 once, and 5 goes into 10 twice. So we need 7½ cups Bisquick to make 25 biscuits. We can do a similar calculation to find out how much water that we need. And for water, we said we had, set this down here. So we know that 10 biscuits for 1 cup of water and we want to find out how many 25 biscuits, how much water we'll need for 25 biscuits. And that we don't know how much water. So just like before, cross products, take that times that, and that times that. So we have 10 times x, and that's going to equal 25 times 1, which is 25. 10x equals 25. So if we look at that, we're going to need to divide both sides by 10 so that it cancels. And remember, just another shortcut here, if we're dividing something by 10, we can move a decimal point over. So in this case, let's do it this way. Say that x is 2.5. And oops, so you can see it there. Okay, so that x, the amount of water, is 2½ cups. Okay, so we figured that out. That we need to make 25 biscuits, we need 7½ cups of Bisquick and 2½ cups of water. All right, so let's go and look at the next problem that we have. So veterinarians, a while back, as early as the year 2000, there were 15 women veterinarians. 15,000 women veterinarians. And the ratio of women to men was 3 to 7. So knowing that, we can use a very similar kind of a problem to figure out how many men veterinarians there were. So we can use this ratio, just like a fraction, and we can figure out how many men veterinarians there were in 2000. Okay, so let's work on that one. Let me try it a little different way. We'll see if it's easier to see. So here, see if it's easier to see and hear. So we want to find out, and actually let me turn off this up here. Okay, so you can see this a little bit better. So we said that the ratio was 3 women to 7 men. Okay, so 3 women to 7 men. So a 3 to 7 ratio of women to men. And we know how many women there were. There were 15,000 women veterinarians in the year 2000. So what we want to do is find out how many men there were. So let's use this ratio to make a fraction. 3 over 7, 3 women over 7 men. And that is going to equal, see how women are in the numerator there? So we need to put this count of women in the numerator there. 15,000. And we're trying to figure out men. So that's X men. Okay? So from there, notice how this is very similar to what we did the last time with the recipe. And we're going to see that that's very similar to the next problem that we're going to do too. So this is 3 times X, because we're doing cross products. And that equals 15,000 times 7. 15,000 times 7. Okay. Now I know, because I worked it out on a calculator, that 15,000 times 7 is 105,000. So 3 times X is 105,000. Okay. So from there, I still need to solve for X. So remember, to get that 3 out of there, I need to divide by 3 so that it'll cancel. But since there's an equal sign, I have to do that to both sides to keep them equal. So I have to divide that by 3. So if I find X is 105,000 divided by 3, let's just do that. 3 into 105,000, just for practice. Okay, so we'll go 3 doesn't go into 1, 3 goes into 10 though. It goes 3 times, that makes 9, leaves us with 1. Now we bring down that 5. 3 goes into 15 5 times. And there we hit it right on the money. And all we have left are to bring these zeros down, but we need to keep filling out here with zeros too. So it's 3 is gonna go into 0 times, 0 times, and 0 times. So we know that there were 15 in 2000, there were 15,000 women and 35,000 men. So the men greatly outnumbered the women by a 3 to 7 ratio. Okay, now, so let me hold that up there just so we can see just for another moment. Okay, now what we're going to do is we're going to go to the year 2016. And in 2016, there were 6 women to every 4 men. And if you look at that, you can see that there's proportionally, there's more women now in at least in 2016, and it's probably even larger now. 6 women to every 4 men. So we'll look at that. And we know that there were 26,000 men . Okay, so from there, let's figure out how to set up that proportion equation. So it's 6 to 4, 6 women, 4 men, and now we're trying to figure out women. So women, we don't know. Women are the unknown here. So now the X goes with women. And notice that we kept the women in the numerator and the men are going to go down into the denominator, and that we have a value for, 26,000. Okay, so there's where we are right now. We still need to figure out what that x is going to be. So once again, what we do are cross products. 4 times x, and that's going to equal 26,000 times 6 times 6. Okay, and from that, again, using the calculator, I know that that is going to be 4x is going to be 156,000. Okay, so that's what I have for that. So what do we need to do? Well, we need to get that 4 canceled. Divide by 4. There's an equal sign, so we have to divide that side by 4. And when I won't do this the long way, but with the calculator, that is going to x, which is the number of women, is 39,000 when I divide 156,000 by 4. Okay, so now we know how to solve for that. So once again, very similar problem. There's the ratio, and there's the thing with the unknown and the one known. Okay, so let's go on back to presentation here. Look at the screen again. Here we go. I think we're back. Okay, all right. So when we look at the veterinarians, we can see that in 2000 we had 15,000 women and 35,000 men, and by the time we got to 2016, we had 39,000 women. They outnumbered men, 39,000 to 26,000. Okay. So let's look at one more problem here. And when we do this, when I was younger in Boy Scouts, one of my Scoutmasters was a math teacher, and I think he taught at East Tech. And we were at summer camp, and it's kind of waiting out by a field, and there was a big flagpole out in the distance. So he said, okay, I want you to tell me how tall that flagpole is. He asked all of us, and we're like 12 years old, and we had no idea. So we thought, well, maybe we'll, we can always stand somebody up next to it and, sort of use our fingers and kind of, work our way up like that and figure out, how tall it is. And so that's one way, and that might have worked okay. We probably could have gotten, within 5 or 10 feet of what the height was. But it turns out that there's actually a way that you can do this. And I'll show you how we did it here. And I actually, my wife was a good sport and actually helped us out in doing these measurements. So I didn't use a flagpole. I used a long PVC piece of pipe. But as you'll see, I'll show you how we did it. So flagpole has a certain height to it, and we'll just call that height X, because that's the thing that's unknown. We don't really know how tall it is, so we're trying to figure that out. Now, fortunately, we had a couple of sunny days last week, and the sun was really bright. We cast a nice shadow on the ground. So although we wouldn't be able to reach up to the top of a flagpole and measure it, we can easily measure a shadow on the ground. We can just use a tape measure and lay it out and measure the shadow on the ground. So that's one dimension that we could get. Now, if we took something that we did know the height of, like a yardstick, which is what we used, we know that that's 36 inches in length. And that's also going to cast a shadow. And from geometry, and if you haven't had this yet, don't worry, you'll learn this. From geometry, if you have two angles of a triangle that are the same, so here we had a nice perpendicular angle, a 90-degree angle. And here we have some angle that we don't know what it is, but we know that the sun is shining down at the same angle. So we know that this angle is the same as this angle. And we know that this angle, which is 90 degrees, is the same as this angle. So if we have two angles that are the same, we know that the third angle is going to be the same, because when you add these two up and subtract them from 180, and you'll learn that too if you haven't already, all of the angles in a triangle add up to 180. So these two triangles, if they have similar angles, they're called similar triangles. And the thing about similar triangles is the ratio of one of the sides to the other side is exactly the same as the ratio of that same equivalent side, so this vertical, and the same side down here. So this is to that as this is to that. And I'll make that a little bit clearer in just a moment. But you can see that there's three of these that we can easily measure. We can measure the height of this yardstick, and we know that that's 36 inches. We can measure the length of this shadow. We can measure the length of this shadow, and we can use proportions to figure out what this height is. So what we did, and I'll show you some actual pictures here of what we did. We took, first of all, a yardstick, and we used a level to make sure that it was pretty much perpendicular or at a 90-degree angle, a right angle to the ground. Then we measured the length of that shadow right there. And we saw that the length of that shadow, you can't quite see it on this, but the length of that shadow was 28.25 inches, or 28.25 inches. Then I'll show you the pole that we used. So we had a big long pole that was a PVC pipe, and we looked at the length of that shadow, and we tried very carefully to keep it straight up and down, and that was hard. My wife was very patient in trying to do that, but even just the slightest little tilting made this shadow change by, an inch or two in either direction or more. But assuming that she kept it pretty straight and that our driveway was pretty level and a lot of other things worked out, we were able to get some measurements, and we saw that the length of that shadow was 96.5 inches. So let's look at what we have so far. So we've got, let's see if I can slide this over a little bit. Maybe not. Okay. So we've got our pole that we don't know the height of. We've got 96.5 inches on the long shadow. We've got a 36-inch yardstick. We've got 28.25 inches on the shadow that goes over there. So let's figure out how we're going to set up those equations. And this should look very familiar now because we've seen it on a bunch of different problems. So we know that the ratio of this to this, so this length, see how that's a triangle, this vertical side of the triangle, and this horizontal side of the triangle, so that's x to 96.5. That's going to be the same as the vertical side of this triangle to the horizontal side of that triangle. So that's 36 to 28.25. So there it is. If we figure out what x is, we should be able to figure out what the length of that pole is. So we'll find out how we did here. But before we do that, we'll run some of the calculations, and some of these just so you can kind of see how this was done. Pop this back. Okay, so just to recreate what we just figured out there, we've got x, and let's see if we get this around here a little bit better. There we go. So we've got x over 96.5, or 96.5. That's equal to 36 over 28.25. So here we're going to use a calculator, but before we do that, we want to make our cross products. We have 28.25 times x, and that's going to equal 96.5 times 36. And if I use a calculator for that, I have 28.25x, and that equals 3,474. That's what that is. Okay, so we're getting close. We just have to divide both sides to cancel this out by 28.25. Divide that by 28.25. 25. Now our x is 3,474 divided by 28.25. And when we do that, calculator, we get 122.97 inches. And we'll just call that, it's pretty close to 123. We'll call it 123 inches. So that's what we calculated for the size of the pole. Okay. So what did we actually get for there? What we found we did it. I know the suspense is killing you. Okay, we got the actual length was 121 inches. So we were really close. we predicted 123 inches, and what it actually was 121 inches. So not bad, not bad for the length of pretty much a 10-foot pole, a little bit more than 10 feet. We were pretty close. So that's a little summary of ratios and proportions. I hope that was interesting to you, and you'll find that a lot of the things that we saw result in the same kind of equation. So we want to use cross products, and we want to figure out how to solve those variable problems where we have a number times x equals something that we need to divide by that number on both sides. Remember to do the same thing to both sides of the equation. And really, once you get the hang of it, it all comes down to reading the problem and seeing what we're actually looking for in the problems. And you can actually solve some real world situations as well with that. So thank you for your attention. Hope this was helpful to you.